So today we'll talk about portable cords. Now, why do we need to talk about this? Here is the idea. When you're just a regular consumer and your job is to be either doctor or car mechanic or pharmacist or whatever profession you can dream of, you can go to Canadian Tire or Home Hardware or Home Depot or Rona or Lowe's or any other store, and you can buy a vacuum cleaner, or you can buy a tea kettle or a hair dryer. Whatever you buy that plugs in, it is produced and packaged and put together and sold in a way that you do not have to be an electrician, or you don't have to have any sort of knowledge about anything that has to do with electricity, and you can use that electric device. It is made for the consumer's use. Now, when you are in more industrial environment, and that also in this case, this includes, excuse me, this includes the construction environment as well. Uh, you are going to deal with certain situations that you're going to have to power up certain machinery, certain devices. And there is not going to be a packaged, let's say, for example, edge bender or planer or CNC machine or whatever else. Um, it is not going to come in the box and with the instruction manual. Okay, you just keep it dry. All right, don't overload it, and make sure you don't touch the exposed parts. But here's the plug and here's the receptacle in the wall, and this is where you plug in. Now it is going to come with some instructions of what is the requirement for which cables to use and what type of power to use. This is something that just a regular consumer type of person would never be able to understand unless they get some training like we do right now in order to plug that in. There's no plug and play. All those consumer devices are plug and play, and rightfully so. That's the way it should be. But when it comes to connecting some bigger machinery or industrial environment, you are going to have some knowledge of how to connect things, what devices to use, what cables to use in order for the installation to be proper and safe and sound, so to speak. Right? So that's why we're going to have this short lesson. And sometimes I'm going to read things and I'm going to stop and go and stop and explain. This is my style of teaching. Simply because if I put a text and talk over that, you will try to read it and you will not hear what I'm saying, and what I'm saying is going to interfere with what we're trying to read, and you will get none of the both. All right. Okay, so here, portable cord. All right, here's a portable cord, which is basically as opposed to a permanent installation in the wall, which we will study as well. So portable cord, which is also known as flexible cord, is a cable with multiple conductors. Well, we already looked at some cables, and yes, they do have multiple conductors, but the NMD90 cable that we looked at, it's meant for permanent installations rather than portable cords. Now, today we're going to talk about the portable cords, also known as extension cables. Uh, okay, so it is a cable with multiple conductors used in applications requiring flexibility. What kind of flexibility? Well, let's say that you need to plug in some sort of diagnostic equipment in mechanics shop where people work on your cars, and there is diagnostic equipment on a card, and it has to be plugged in. So we would use a portable cord, and that thing is on wheels because it has to be mobile, because sometimes you want it close to the left side of the car, sometimes you want it close to the right side. You get the idea. Flexibility is required. The cord can be used to provide power for a range of applications. Well, self-explanatory. such as small hand tools. Yeah, that's another example. Movable equipment, which is well, it's just I gave you that diagnostic equipment, for example, or a vacuum cleaner. That's a movable equipment. Power extensions or home appliances. All right. Mind you, when it comes to using portable cords, it is a portable cord for a temporary use. You can't have a portable cord plugged into the receptacle in the wall and have it as a and use it as a permanent installation. Right? If there is something that is more than few feet away from the receptacle, then maybe you should move it to the closer receptacle, or maybe you should get a request to install a receptacle that's close to that piece of equipment. Okay. All right, so and here are the examples of portable cords. Something you buy in some local hardware store. These are well, the regular power bars, and the good old thing is the extension cords that you would use for, well, pretty much anything else, for your lamp or some Christmas tree lights, which technically they should not be used because outside this thing is not meant to be outside. You should get an extension cord or portable cord that is meant to be outside in a cold. All right, so let's take a look at some of that. Portable cords, continuing. Portable cords might be used in a commercial, industrial, or residential applications. Whoa, here's a mouthful. I think we are on the same page still. They work well on job sites where resistance to, and here is the, this is where the fun begins. Where resistance to oil, chemicals, and abrasion is important. Okay, portable cords work well on job sites where resistance to oil. So the best example would be a car shop, mechanics shop, where they fix cars. Uh, the floor, the walls, the ceiling, everything is covered with a tiny film of oil. Oil is everywhere, or oily substances, or any other chemicals that are being used, because that's where that this is basically when they are present, and you can't escape the fact that they are going to be around and things are going to be in contact with them, including the portable cords. Why do we need to have them resistant to well, withstand the contact with oil, chemicals, and abrasion, which is basically physical, you can say, abuse. Um, uh, because if they are not resistant to oil and other chemicals, the insulation or the jacketing could get compromised and the electricity is still there. So the cords, the portable cords, you're going to find that pretty much all of them will have the conductors made out of strands. So you would not find solid core conductors in the portable cords. You will find stranded conductors there because you need flexibility, and this, as you remember, we studied the differences between solid core and stranded, the characteristics, the advantages and disadvantages. You could tell that the stranded cords or stranded conductors are more flexible. They do not get damaged as quick as the solid core wires would when moved around and wound and coiled and all that stuff. At some point, I'm going to show you, maybe during one of those labs, how to properly coil the cable. There's a certain way of storing portable cords as well. I can't show this thing to you on video because I'm just having this camera here. But when we see each other during some labs, please remind me to show you. I'll show you the way that if you store them in a certain way, physically, from the physical aspect, they will last you a million years. Well, maybe not. Okay, so again, oops, here. Portable cords work well on job sites where resistance to oil, chemicals, and abrasion is important. This would not be your typical household environment, because how in your house you don't have anything splashed with oils and chemicals. Well, most of the houses. Okay. All right. The construction enables them to perform well in extreme environments, both heat and cold. All right. Outside or inside. Additionally, some portable cords can be water resistance and water submersible. So, as you can tell here, the portable cords are made with some extra aspects in mind, that they're supposed to withstand physical abuse, and they're supposed to withstand exposure to elements such as weather outside, or chemicals that normally you would not find in a regular household. So you're talking industrial environment, including construction. Okay. Now, not all the portable cords are made the same, and we're going to take a look at some of that. All right. So here's the thing. Okay, common types. Here's the common types: SJT, SVT, SEOW, SJ, SJOW, SO, and SOW. Now surpassed by the SOOW type. There you go. Got it? Got it. All right. What's SOW? Well, SOW. Okay, so the letters correspond to the characteristics of okay, so what's SOW? SOOW. All right. It's made out of rubber. um it has a greater dielectric strength. Okay, let's get serious here. Dielectric, we know dielectric is the opposition. It's something that opposes the conductivity. All right, a conductor. The opposite of dielectric is a conductor. So dielectric is basically something that does not conduct current, which would be an insulator or isolator, not insulator. And it has higher tear resistance. So here's the SOW. Maximum conditions temperature is 90 degrees Celsius plus, and maximum condition temperature is minus 40 degrees Celsius. So that's the SOOW. Now here's the SEOOW. Okay, it's a thermoplastic PVC. Here, what is thermoplastic? Thermoplastic material is a material which can be heated and cooled down, and heated and cooled down, and heated and cooled down multiple times, again and again and again, and it will not lose its properties. It will stay as it was. As when it was stretchable or elastic or whatnot, it is not going to lose its physical properties. Some things, well, let's say something that would not be thermoplastic. Well, let's say it will be a pizza dough. Okay? Pizza dough is nicely moldable, just like plasticine, but you expose it to heat and it turns solid. It stays that way and never comes back to the previous state. Extreme example. So these are not pizza dough. You can heat them up and cool them down, and they will remain as they were. Thermoplastic, all right? Elastomer or elastomer. What is that? Well, it's an elastic material. Any materials that are that display that manifest elastic properties. Is rubber an elastomer? Yes, rubber is an elastomer. Is a vacuum cleaner hose elastomer or elastomer? Yes, it is, because it displays or manifests elastic properties. Is your rubber band that you tie around your hand sometimes and you can snap it, yes, it's also an elastometer. Okay, maximum conditions for that SEOW, it would be 105 degrees Celsius, and minimum conditions temperature would be minus 50 degrees Celsius. So I was just talking to you about here the designations: SJT, SVT, blah 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 blah. Okay, let's go to the next page. Here is the explanation of what is what. Okay, so when you see the letter designation S, that means is a severe, well, it's a service cord, but it's a severe service cord, which is basically one step above the junior service cord. What's a service cable or service cord? A service cord, remember when we talked about before, it is a cable or a cord or a conductor that is supposed to provide, its purpose is to provide power that we can use. Those overhead cables that go from the hydro pole to the little thing, the post that sticks out of your roof of the house. These are the overhead cables. They are called service cables because they provide power. Anything that, so get the idea, right? As opposed to, like, for example, a microphone cable, which is not a cable to provide power. You try to get the same power through the microphone cable, then you see that thing disintegrate right before your eyes. It is a signal type of a cable, Ethernet cable that is providing the Ethernet signal from the Ethernet jack to your computer is not a power cord. It's not a service cord. It's a signal data cable. So service cord or service cable is a cable that is supposed to provide power. Now, let's see the differences between severe and junior. Okay, so you see S, and sometimes you're going to see SJ. There is a little bit of a difference of what they're supposed to carry. The S stands for severe, and it's rated for 600 volts, up to 600 volts. And also when you see designations on the cable like 277, 480 or 480, these are volts. Of course, because its maximum rating is 600 volts. And you might ask, what about the ampacity? Is there any, are there any designations that talk about what currents they can? Well, the ampacity and the current, you look at the gauge of that cable, and that's how you can tell how much current or how many amperes it can carry. Right? This is what these are talking about, the voltage. So the dielectric is supposed to withstand the electrical pressure between those two wires and not pass them through, because it's supposed to provide the power and you connect it at the other end. And that's where you get that power. So the voltage is not, the current is not supposed to jump through the insulators, and this is, and the voltage is basically the electric or electrical pressure. So when you see S, then you see 600 volts, okay? And it might be utilized in place of SJ or extra severe service. We're not going to talk about extra severe, but here we're talking about SJ for now. SJ is also a severe service cord, but the J stands for junior. So it's a junior severe service cord. And look at that. The service cord is supposed to withstand 600 volts, and the SJ, which is a junior severe service, and it is supposed to withstand 300 volts. And of course, when you see designations like 120 or 120 or 208 or 120, 240, blah, 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 but not 480. Because some of the cables will have volts, which is supposed to withstand the voltage of 277 or 480 volts. Then you cannot use this junior cable as J cable, because it is only able to, it's rated only for 300 volts. Okay. Then you're going to see designations like the capital T, which stands for thermoplastic. And as we talked about a couple of minutes ago, the thermoplastic properties, it means that the material can be heated and cooled down multiple times, and it will keep its physical properties. It will not change. It will be still as stretchable, still as flexible and whatnot. Then we are talking about heat resistance or high heat resistant, and there are some temperatures to be mentioned later on. N stands for nylon outer jacket, right? Nylon outer jacket. And elastomer, thermoplastic that looks and feels like rubber. That's another description. But elastomer is basically property of elastic materials. Like for example, rubber is elastic. Right? Then here is the O and here's the double O. O stands for oil resistance outer jacket material. Those, well, the oil resistance, the biggest thing that comes to my mind is the mechanics shop where people work on your cars. There are a bunch of oils everywhere there, and they're going to be on that cable. And when that jacket comes in contact with those chemicals, it is not going to be compromised now or 2 months from now or 6 months from now. It's supposed to withstand the contact with oils and other chemicals, but this is for oil. And then there's the double O, and it's oil resistant outer jacket and oil resistant insulation. So it's a double insulated for oil resistancy or resistancy, resistance. Right? And then there's that V, it stands for vacuum, simple, typically used with vacuum cleaner and other portable cleaning equipment. Vacuum and cleaning it was, that's basically where the custodial staff is using those machines. And there are certain cleaning chemicals and there are certain cleaning chemicals mixed with dust and all that stuff. So you need to get, and plus they're coiled and uncoiled multiple times. So you need a cable that is going to withstand all that abuse. If there's any, well, vacuum cleaner that's being used in the industrial environment, that power cord or the power cable, it's probably taking the most physical abuse and the most chemical abuse, and it has to be able to withstand that and still be intact and still whoever is using it, they would have to be safe. Oh, then there is the W, also the CSA regulations. Weather or water resistant. So when you see the W, that means you can use it outside or inside. Right. So sometimes you're going to see a cord, portable cord, that you're going to see, oops, you're going to see things like this. Can I see that? Yeah, there. You're going to see designations like that. And where are you going to see them? You're going to see them printed right on the cord. Right? That's where you're going to see those things, or on the packaging. So let's take a quick look at this thing here. You're going to see a designation like this on a portable cord. So we're going to see S. Okay, so that's a severe service cord. That means this cord is a power cord. It's supposed to provide power. So, but then do we see J after that? Yes. All right. So can we use this? Can we use this thing with applications that need 600 volts? No, we can't, because there's that J here. So that means it's a hard usage and it's rated for up to 300 volts. Right? Then what do we see here? E, that's the next one. How can you read that? Oh, it's a thermoplastic or thermoplastic PVC. Okay, well, sometimes you're going to see the T and sometimes you're going to see the E. So thermoplastic type or thermoplastic PVC. So there you go. Okay. In Canada, E becomes T for the TPE added after the other letters. So you're going to see SJT all W, for example, instead of the E. Okay, so that's basically where you look for the answers when you see things like that. Then what do we see? We see the O, so it has to be oil resistant. Okay, do we see another O in there? Because if it was just a single O, that you would need the only resistant outer jacket. But is there another O beside that? Yes, there is. So it has to be oil resistant outer jacket and the inner insulation as well. Right? And then what's the next one here? Um, there's a W there. Well, that means it's weather resistant. That means you can use it outside. It's not for indoor use only. If you don't have that W, that means you can't use that thing outside. So if you don't see the W there, you can't use it for Christmas lights. All right. Using the chart below, define the following types of cables. And that's, well, we already did this here. So we already have done one example. Uh, and I'm going to leave you with this. And when next time we see each other, we're going to take a look at this. Okay, so it's SEOOW, was SOOW, then was it THHN, or was it THW? So here's the heat resistant, okay, or the high heat resistance. We're going to have to find out what the temperatures are. So I will leave that with you. There's a nylon outer jacket. So I will leave this with you. Just sit down and just practice some of that, because those things are going to be on the test, but never mind the test. Become comfortable with the topic, because you never know when you're going to have to use it. And when it comes to you doing your job and some sort of machinery shows up that you need to connect, then you're not going to be silly and just go to hardware store and buy certain type of any portable cord off the shelf and just plug it in and use it and be happy. You are going to be conscious of that. You're going to find out what are the requirements as far as the machine. What is the voltage that the machine requires? What is the current consumption that the machine requires? And you're going to be conscious of the environment that the machine is in. So then you will just not go and pick anything off the shelf. You might actually have to call some of your distributors, electrical distributors, and you're going to maybe have to order some sort of a cable that fulfills certain requirements. Where are you going to see those designations? These designations you're going to see on the cables or on the packaging of the cables as they show up, or on the reels, uh, or you're going to see those in the um, documentation that comes with the machinery as far as requirements of how things are supposed to be connected. So you're going to see some of that as a minimum requirement. And also you might see some mention of that, well, depending on the environment that this thing is in, then there might be some additional requirements that you will need to fulfill when choosing the proper cord. Okay, so now you just had the little bit of another dose of the blue pill. I'm talking about matrix. Well, you just got that little bit more knowledge in your wonderful brains that you did a few minutes ago. All right, so as I said, this was going to be a little bit shorter lesson. I realized that the previous lessons and the previous couple weeks or 2, 3 weeks, I have loaded you with some information that you needed to spend a little bit extra time on reading and watching the videos. Speaking of which, there's one more video that I have posted on our YouTube playlist. Let me see. Um, Here, this is our class portal. You scroll down the announcements until you hit the YouTube playlist. And I'm talking about this video right here. And it is reading voltages on analog display. It's a 16-minute video. You click on that. I'm not sure if you could hear the sound. Usually you can't hear the sound, but I have put analog display and deflected the needle, and I showed you and I'm showing you how to use different scales to get to read the same uh, quantity, measured quantity, like voltage, for example, but you can use different scales, and using this method that I'm showing you, you're going to come up with the same result. Of course, you're going to come up with the same result because the the measured voltage hasn't changed. What has changed is the way you're reading it, but your reading is supposed to reflect the truth. So I'm showing you that. Go over that. It will be on the test. I want you to be comfortable that when you have one of those in your hand, one of these in your hands, then you are going to, well, you're supposed to be familiar with this type of stuff because, well, you're going to be working with this type of stuff. Okay, so that's pretty much it for today. Are there any questions about anything that we have done so far? Um, just go back here and go back here. By the way, when it comes to writing quizzes or tests, that YouTube playlist, there's a reason I'm putting those lectures on the YouTube playlist, so you can go and search for the answers. Yes, it's an open book test, but I arrange the questions in such a way that sometimes you're going to have to search for the answers, and that's how you learn still, and this is how you solidify the information that I'm giving you in those lessons. And this is how you turn the information into knowledge. The difference between information and knowledge is that, for example, you have a recipe on how to bake a loaf of bread, and you follow the recipe to the T, and for the first time, almost guarantee you that whatever is going to come out of the oven, it's not going to be a bread. It's going to be some sort of a dry brick or something that you can't eat. And then you're going to consult your friends maybe, or search more and do some more trial and error. And after a few tries, yes, you're going to bake bread. So the recipe, just the recipe, is the information. But after you are actually able to use that in a way that it's supposed to be used, that, well, it's useful, and you know how to do it, then you possess the knowledge, right? So when I'm doing those tests and you're searching for the answers, you're solidifying that information, and you're becoming a little bit closer to possessing not just the information, but actual knowledge on how to do things. And that is also reinforced with the practical activities such as labs. And that is also later on going to be reinforced with your experience on the job, which that will never end. Okay, that's the beauty of the experience. There's always something new that you're going to learn. Okay, before I start writing poems and get a little melancholical, uh, I see no questions, so that means everybody knows everything. And if you just can't think of anything and something comes to your mind later on, please shoot me an email. And well, that is it for today's class. Please enjoy your weekend, guys. Oh, thank you very much. Yeah, you're welcome.